This lesson is about non-numerical systems. It's just a good way to practice some properties of systems. These questions are also really popular in standardized tests. Like ACTs love to put these questions on here with charts and symbols you've never seen and see if you can use logic and interpret in a new or different situation.
And why did no one teach us this for junior year?
Yeah, it's one of those things that's why I really like playing this class, is this is all the stuff that doesn't fit into another class, but is still good to know. So what we do is we define an operation with a chart. So, I mean, we have operations that are defined, like addition and subtraction and multiplication and division, and we can do like times tables. So this is some sort of a number table, except it's not numbers, it's letters. And the symbol in this one is an asterisk, but sometimes they use question marks or whatever symbol there. We always start when we're evaluating something by looking down the column first, or down the rows, that first part, and then looking across the top. So what
all students may return to the building at this time. So again, all students can return to the building, and please return to your 7th hour. Thank you.
When I do X star W, I'm going to start with this X and W and see where they meet up, and that gave me a Y.
Seriously?
Seriously. I'm not lying.
Oh, no.
So then the next one is Z, and I go until the Y column, and that gives me Y.
I don't get. I'm just kidding.
Well, I think the contact.
Excuse me?
The next one is Y,
You need to leave.
Z, and I go Y.
Why is it all Y?
I don't know.
Yeah, that way.
I guess I wasn't really careful when I
Like I
picked the
almost
problem.
don't understand this because it's so easy.
The next one is
That was wrong.
W, Y, and we get something different. We get a Z this time.
Oh, well, what about the next problem?
So the next one has some order of operations involved in here. Parentheses always happen before other things.
Oil.
So, well, it's not, like, there's not a plus. So we don't need to do any distributing, but we're going to work out what's inside the parentheses first. So my chart's getting pretty marked up here, so I'm going to erase all my junk from the chart. And then we're going to do the inside first. So we're going to do the W star Y first, and that gives me X star Z. And then I do X star Z is X. So do what's inside the parentheses first, and then do it with whatever's outside.
So then you do W, Y.
So on the next one, we're going to do what's inside first. So we're going to do the XW. XW gives Y. And then Y star Y gives X. So in our last lesson, we talked a little bit about what a group is. And a group has 4 criteria. So each of these questions is one of the criteria for a group. If they're all yeses, then it's a group. If there's anything of these 4 questions that are not true, then it's not a group. So the first one is it closed? So the inputs were W, X, Y, and Z. So then we look within the chart and see, did anything else show up in the chart other than those? No. The only things in this problem are W, X, Y, and Z, so it is closed. So if your outside values are W, X, Y, and Z, but then somewhere in the chart there's an A, that's not closed. An identity is something that we can apply that will give us back exactly the same thing as we started with. So the best way to look for an identity is to look through the chart for like a column that matches the starting column. So W, X, Y, Z. I want to look and see, is there a column that says W, X, Y, Z? If so, that's the identity. So what's the identity?
Z.
Z. Right here, I get that W, X, Y, Z. So Z is our identity value.
Is there tuna in here?
I was just eating chicken, I'm sorry.
Was it chicken stew?
Yeah, I was wondering. It was like chicken tuna, I'm sorry. I forgot to eat because I had my biology class and then I realized I had my lunch. I'm sorry.
Cumulative is harder to test. It means can we regroup things, which is specifically why I included these two problems. Notice they're both x, w, y, but the only thing that changes where the parentheses are, and we got the same answer for them. Now, just because that one worked doesn't mean it's going to work for everything. You would really need to test and see, like, is it working for everything? But we're going to go with yes, just given that one example here.
We'll get this chart on the test, right?
You know, I don't remember if there are any questions about this on the test or not. I'll look that up. An inverse means, is there something that I can apply to each letter to get the identity? So we said our identity is z. So that means, is there always a way to get a z? So for w, is there a way that I can get a z?
Yes.
For w, what would the identity be? Y. Or the inverse, rather. For x, is there a way to get a z? What is it? X.
Wait, I don't get this.
So we're looking for that letter z. Since z was our identity, we're saying, what do I have to do to w to get a z? I would have to apply the y.
Oh,
Wait, why did we decide that Z was the identity again?
Because z is the letter that gives us back exactly what we started with. So the z column exactly matches our starting column. So then for x, if I apply x, I get a z. For y, what do I need to apply? A w. So y goes with w. And then for z, what do I need to apply? Z. And that's it. So since each of them had an inverse, that's yes, and this is in fact then a group because all four of those worked. We didn't really fully test out associative. You'd have to try everything, and that's quite a long process. One more thing that we can say about an operation that it doesn't necessarily make it a group or not a group, but a question that we often ask about them is it commutative? Does anybody remember what commutative means? We did talk about this in Algebra 2. About like your morning commute, right? You go to work, you go home from work, same thing but backwards. So commutative means if I do 1 times 2, is that the same as 2 times 1? Okay? The easiest way to tell in a chart if it's commutative is to go down the diagonal and see then does everything else reflect. So y, y, z, z, w, 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 x, x, y, y. Could I fold it on that diagonal and have everything match up? And if so, it is commutative.
So this one's
Okay, so this one is commutative. That doesn't make it a group or not a group, but it is something that we ask about number patterns a lot. So if you can fold it on the diagonal and get back the same thing on each side of that diagonal, it is. If they don't match up, then it's not. And that's it.
So then, oh, this is